So, time for our next speaker, who, much like Roy before, was also part of the early alt.net movement. Also like Roy, he divides his time between software and music that we got a sort of evidence of here. But quite unlike Roy, that combination did not give birth to a startup. In this speaker's case, it gave birth to a programming language, aptly named Rockstar, where the lyrics read, where the code read like the lyrics of a power metal ballad. And he shared with me that he actually spoke on an event here in Malmö a few years ago and was given a cup, a coffee mug, that he has been using in Zoom meetings since then. There is some Swedish text on it, and at some occasion somebody asked him, "Do you know what that text says?" And it reads, I quote, "Jag är en vacker och genomklok och lagom tjock man i mina bästa år." That in English, for the non-Swedish speakers, translates to roughly, "I'm a beautiful, all through wise and perfectly fat man in my prime." Which is a quote from a Swedish kids story character called Karlsson på taket. And before handing over the word, I really need to come back to this Rockstar thing. I checked around, found some example code. It's fascinating. I found the sample code for the, Hello World program. The code is too long to share here, but the last few lines of that program reads like this: "Time is all up. Cast it into the void. Let fear be with the void. Let fear be with hope. Shout fear." That makes absolutely no sense to me, but I think there is some logic in there. Please welcome Dylan Beattie.
Hey, beauty and code. How you doing out there? So, I'm Dylan Beattie, and this is the story of typography. And you know that because I have a slide that you can read. And it says, from hot metal to HTML, the story of typography. Now, I want you to look at that slide for a second, because there is more going on than just the words. What if that same slide looked like this? Now, you might be thinking, well, now what kind of talk are you expecting? If this was the front page of a report or a newspaper, yeah, you wouldn't think about it. On a PowerPoint slide, it's a slightly odd choice. Like this one. Folks at the front are like, oh, that looks very minimalist and elegant. Folks at the back are like, what? Actually, this is a pretty good screen. You can probably see it. What about if I came up here and I said, "Hey, welcome to my talk." And you'd be like, "Oh, cool, he's going to tell us about pirates and King Henry." Or I got up here and I said, "What about this one?" It's kind of like an aggressive military stamped on the side of ammunition crate. Or we could go with the Nordic death metal font, which you don't know who the band is or when the gig is or anything. You just know that it's metal, right? Or I could use the world's most controversial typeface. But after going through all of those, I'll come back to this one. This one kind of doesn't say anything, really. And this font, this is called Frutiger. It was designed by this guy, it's Adrian Frutiger, and this font was created as part of a project to redo all of the signs at Charles de Gaulle Airport in Paris in the 1970s. And Frutiger was a typographic minimalist. He had this wonderful quote. He said, "If you remember the shape of the spoon with which you just ate some soup, then the spoon had a poor shape." And he felt the same way about type. He's like, if you look at one of my signs in the airport and you remember the font, it means the sign didn't work. And so we are going today to explore the history of typography and letters and alphabets and shapes and signs. And we're going to start here, about 5,000 years ago in ancient Mesopotamia, the part of the world which is now Iraq. And this is a turning point in human history. For the first time ever, human beings are no longer hunters and gatherers. They have settled down. They are growing crops, they are building homes and settlements, and they have a problem that human beings have never had before. There is too much food. It's not something we'd ever experienced before, but in a good harvest year, they have more food than they can use. And so the priests say, well, we got a good idea. Why don't you give us all the food, and we'll keep it safe in the temple, and then next year, if there's no food, you can have it back. And they needed a way of keeping track of who had left their food at the temples. And so they would make marks in clay tablets. They would draw pictures, a picture of a cow, a picture of a bushel of grain, little tick marks to show how many cows and how much grain. Now, This system worked for a while, but at this point, we human beings, we've been using spoken language for tens, hundreds of thousands of years. We've gone way beyond just counting how many cows there are. Now, we're going to do a little bit of audience participation here. We're going to have a little quiz. What I want you to do, I'm going to show you a picture. I'm going to count 3, 2, 1, and then I want you to shout the name of the country, all right? You all good with that? And you all get to shout together, so nobody has to go first. So, 3, 2, 1. Australia. 3, 2, 1. Very good. How about this one? 3, 2, 1. France. 3, 2, 1. Gonna get a little bit harder. 2, 1. Who said Portugal? Oh. Spain. The Kingdom of Spain. How about this one? 3, 2, 1. Thailand. Thailand. How about this one? 3, 2, 1. Romania. Now, these are all different kinds of writing systems. Try one more. Anyone? 3, 2, 1. Canada. Yes. Written in Japanese. Kanada. Now, these are pictograms. If you know what shape Australia is, or you've seen the Eiffel Tower, you don't need to study the alphabet or learn the language. You just recognize it. We communicate by literally making a picture of the thing that we want to talk about. Now, pictograms are a fantastically powerful communication mechanism. Not like talking hard. Tokyo Olympics, 1964. It's the first time there were like large numbers of international visitors coming to Japan at the same time. And they needed to figure out a way. These people don't speak or read Japanese. We need to show them where to go if they want food, drink, refreshment, showers, airports, all this kind of stuff. And they invented a set of pictograms that are now used all over the world, and we just kind of assume they've been around forever. You want to eat something, you look for a picture of a knife and fork. Which is, you know, this is Tokyo, 1964. Knives and forks are a Western thing. Tokyo, most people are chopsticks, so they're like, no, we'll do a picture of the thing they are looking for to create that association. If you're thirsty, you look for a picture of a cup of tea. If you need to take a shower, you look for the picture of the shower. But going back to ancient Mesopotamia, the Mediterranean, a couple of thousand years before the birth of Christ, something is going on. One, these pictures are spreading. And as they are spreading, they are getting streamlined and simplified, and they are getting rotated sideways to a point where even if you've seen a cow before, you're not going to look at that and recognize it. You needed to learn what it meant. You had to be aware that this symbol stood for the idea of a cow. Now, this is called an ideographic writing system, and these are still in use all over the world. Here is a great example. We all know what this means, right? Because we've been working remote for 5 years, and we know that if you want to talk to someone, you click this thing. Is this a picture of anything? Like, I don't have a little circle above my head with words in it right now. It's an ideogram. Once you learn that sign means chat to somebody, it becomes ubiquitous. Now, one that I particularly love is something that has gone from being a pictogram to being an ideogram without changing in my lifetime. And it's this one. Because when we first saw this symbol on a computer screen, it was a picture of the disk that you'd get out the drawer, you put in, you click the button, and obviously that's the visual association. And now there are people out there who have never seen a floppy disk who know that that symbol means save. And then they find a floppy disk in Mum's desk drawer, they run downstairs, Mummy, Mummy, why do you have a plastic save button? Now, ideograms can be culturally specific. And I'm talking very, very culturally specific, like something only a few dozen people agree on. You ever had the thing where you're in Slack and you post a question and somebody replies with eyes? Now, most Slacks that I'm in, the eyes mean, I am looking at this for you now. I'm in a couple of Slacks where the eyes mean, oh, I'm going to watch this, because I also want to know the answer to that question. Now, apparently in Slack, the eyes officially mean let others know you are looking into this. But if I send my girlfriend a text message and she replies with the eyes, it doesn't mean I'm looking into this for you now. It means I am rolling my eyes because I can't believe you are that stupid again. Context. Ideograms are used when we have something that we can't draw a picture of, or maybe something we don't want to. Another example from the Tokyo Olympics, this one. First time this sign was ever used. And this has become ubiquitous, international, and that Olympic opening ceremony, all the flags coming out onto the Olympic parade pitch there. You know, we know that that means Norway, that means Spain, that means the Olympic flag, the flag of the Olympics, because we've learned it. You're not going to figure this out from first principles. And then these ones are phonograms. The picture represents a sound. And this was what unlocked the power of spoken language. These three words, they all say the same thing. You may not be able to read them. You may not be able to understand the alphabet they are written in, but if somebody read that out loud, you would go, Canada, Canada, Canada. They are the same sound in three different alphabet systems. And this goes back to, we don't know exactly when, and we don't know exactly where. Probably happened a couple of different places around the same time. But at some point, that cow lost its horns, got turned completely sideways. Now, the ancient Semitic word for a cow was aleph. And so this symbol came to stand for the sound ah. There was another early sort of hieroglyphic symbol, this one. It's a little picture of a house. The ancient Semitic word for a house is beth. This got simplified and rotated. And then the ancient Greeks got hold of it, and Aleph, Beth became Alpha Beta, which became alphabet, and we'd invented alphabets and written language. Now this is cool, because you can do all kinds of stuff with this, but we need to invent a couple more things for the next part of our story. We want to invent books. Now, to get books, we're going to need two things. We're going to need paper, and we're going to need a way of printing on it. And what I find is quite incredible is paper and the thing we'd recognize as a book, they were invented at the same time, about 100 years AD. But there wouldn't be a paper book for another 1,000 years, because paper was invented in China around the 1st century, but they used it to make scrolls. And books, what they'd call a codex, this idea of two hard covers with sheets between them, that was invented in Europe in the 1st century, but they made them out of vellum, parchment made from animal hide. Nobody kind of put the two together for nearly 1,000 years. And when they did, it sort of happened all over the world around the same time. But if you wanted to make a book, you had to copy it. Find a Bible and get someone to copy that for you. Or find some friendly neighborhood monks to copy it. It would take a couple of years to print a single one of these. And what revolutionized this was the invention of the printing press. Now, most people kind of believe, like the accepted history, certainly in Europe, is that the printing press was invented by this guy, Johannes Gutenberg, the inventor of movable type. And to know why that's a big idea, we've got to understand, well, what was type and why was making it movable such a big idea? Now, the word type, we're developers, right? If type of type equals type, you type your program here. And if you press the keys really hard, that's called strongly typed programming. And if you press them gently, that's weakly typed programming. But all of these words, you know, we talk about types, we talk about data types and structures, we talk about typing on a keyboard, we talk about types of dog, types of car. All of these words came from printing, because a piece of type was this. The word type comes from tuptain, which is a Greek word literally meaning to punch something, to leave an impression. The earliest examples we found of this kind of movable type printing are actually Chinese. Around the 8th century, this guy, Bisheng, who no one's heard of him, but there's a crater on the moon named after him, which I think is really cool. He invented a movable block typing system made out of porcelain that used a combination of wax and ash as ink. But it didn't really catch on around the world. It was Gutenberg who popularized it in around 1450, and his contribution to this, the Gutenberg press was kind of like the iPhone of the 13th, 14th century. He didn't invent all of it. He took a lot of ideas that already existed, and he just put them together in a device that worked really well. And the key to that was he was a goldsmith, and he made his printing press out of metal. 3 different kinds of metal. First of all, you got the thing on the left here. This is a punch. This is made of steel. You take your punch, you take a piece of brass, you put the punch, you whack it with a hammer, and you get a hollow impression. It's called a stereotype. Then you take this thing, you clamp it in a little mold, and you pour in molten lead. There's a lot of molten lead in this story, and you get these pieces of type, and they are all identical. You take a couple hundred of those, you put them in a frame, clamp it in place, cover it with ink, slap it down hard, and you've printed the first page of your Gutenberg Bible. Gutenberg printed, the Bible was his first kind of major printing project. It took him about 5 years to print fewer than 200 of the famous Gutenberg Bibles. Many of these still exist. They're in museums and libraries all over the world. 5 years to print around 180 of these. We're going to skip forward 5 centuries, because we can do that. 1950, in the United States of America alone, there were 50 million printed newspapers being distributed every day. So we've gone from 200 Bibles in 5 years to 50 million newspapers overnight, and we are still doing it using movable type, hot metal, and ink. And the thing that made it possible was engineering ingenuity, and one of the coolest machines I've ever seen anywhere in the world is this thing. Anyone know what this is? It's a linotype machine. Now, I first saw one of these at a museum in Berlin about 5 years ago. I was just like, that is amazing. I need to figure out everything about this and how it works. And a couple of weeks ago, I went down to Amberley, which is in the south part of England, near London, where they have one of these in their museum print shop. And they let me go in and take pictures and poke around for a little bit. Now, the key to the linotype machine is this thing. It's called a linotype matrix, and if you look very closely, you'll see that set into the middle of this are those 2 stereotypes. This is the thing that lets us cast molten lead into printing plates. But if you look at the top of it, it's got this set of teeth. Now, this is a 7-bit binary coding system from 1886, when this machine was invented, and it's the key to what makes the linotype machine work. So we're going to do some linotyping. We're going to set ourselves up. This is our machine here. First of all, we've got to choose a font. And when I say a font, we are going to take a thing called a magazine, which is a huge metal tray with hundreds of these brass matrices in it. This thing is heavy. Like, don't drop this on your toes. We're going to clamp that in place at the top of the machine. Then we are going to fire up the crucible, because there is a bucket of molten lead attached to this machine with a gas burner underneath it. Gets up to about 300 degrees Celsius. There's literally this bubbling pot of molten metal. We're going to adjust the seat, you know, get the lamp right, and we're going to sit down at the keyboard, which predates QWERTY by about 10 years, and we are going to type out our word. And every time we press a letter, one of those matrices is going to drop down the magazine. It's going to go into something called the assembler. When we get to the end of a word, we're going to pull the handbrake. There's no spacebar, there's a handbrake lever, and that is going to take one of these and wedge it into our row of type. Now, this thing is a separator, and if you look closely, you'll see it's kind of arrow-shaped. It's not completely linear. We type another word, we pull the handbrake again, type another word. Eventually, we get a line of type, linotype. Then we pull another lever, and all of these things get whacked into place, and we get justified text. It expands the whole thing to the width of a newspaper column. Then we pull the third lever, and the bucket of molten lead injects molten metal into this thing, into the mold, and we get one of these come out the other side, a linotype slug. Do that a couple of 100 times, you have a column of newspaper. Do that a couple of 100 times, you can make the front page of a paper. Those little matrices, they go back up to the top. They get threaded onto this thing, the distributor bar, and they go along, and when they get to the right point, they drop off, they go back into the machine. So you can just go round and round and round. You can reuse these pieces over and over again. You get a printing mock-up or a printing plate that looks like this. You stamp that into plasticized papier-mâché, and then you fill that with molten lead inside a drum, and you get the actual printing plate that was used to print the last hot metal edition of the Sunday Express newspaper in 1986. Now, linotype machines are astonishing. What I love about them, I think they are possibly the most complicated machine ever made that you can still understand just by looking at it. There's no microchips, there's no firmware, they don't download any updates. They are incredibly complicated. Thomas Edison said that they were built with the precision of a watch and the power of a locomotive. And you can watch these things working and kind of figure out how they did this. The New York Times had 1,000 of these things. At the peak in the 1970s, there was something like 100,000 linotype machines around in the world. And then overnight, they just stopped being a good idea. And most of them have now been sold off for scrap. There's around 1,000 still in working order, mostly in museums around the world. The machine just wasn't the cheapest way of making newspapers anymore. And it got shut down. They made the last machine in about 1970, but the Linotype Corporation still exists. And the reason that they still exist is they had the machines, they had the spare parts, they had the molten lead supplies and everything, but they also owned the fonts, the typefaces that were used to do this. And typography and fonts are just as in demand in 2023 as they were in the 1950s, 1960s, all the way back to Gutenberg's Bible. So what's the big deal? Well, let's design a font. We're going to take a capital letter, capital vertical bar. You know, how hard can it be to design a vertical bar? Well, maybe we want rounded corners. Maybe we want straight corners. Maybe we don't want it to look geometric. We want it to look flourished, like it was drawn with a marker pen. Or maybe we decide geometry is perfectly good enough. We're going to go back to our kind of, you know, solid rectangular thing. We'll stick another one across the top. Yay! We've invented the letter T. How tall should it be? Is it a little squat T? Is it a sort of very tall, spindly T? Are we going to make it a really thin, lightweight font? Are we going to make it a really heavy, like a sort of almost black letter type font here? Do they have to be the same size? What about the corners? What if we put little bars on the corners? These are called slab serifs. What if we put little crinkly edges? What if we combine the two? We move these in. This is just designing a T, you know, it's two straight lines. What about a letter Y? Is a letter Y two straight lines? We bend one of them. Maybe we bend all of them. Maybe the whole font shape here is made up out of curves. We take the O. Is the O a circle? Or maybe it's a rounded rectangle. Or maybe it's a circle that we've squashed ever so slightly. Or maybe it's a circle where the hole in the middle is a slightly different shape to the one on the outside. Is it vertical? Maybe we're going to align it slightly. That looks good. We're going to draw a line down it. We got a P. We're going to put flourishes on the end of the P. We're going to take the E. Where is our crossbar? Is it up here? Is it down here? Is it horizontal? Are we going to put it at an angle? Is this sharp corners? Are we going to kind of smooth this out a little bit so it looks more organic? Designing a typeface means making every one of these decisions, and dozens more besides, over and over again for every single letter and number and punctuation mark in an entire alphabet. And this used to be done by hand. This is the hand-drawn sketch from a guy called Stanley Johnston, who designed the Johnston typeface that's used throughout most London transport networks, the London Underground. And it was meticulous. They'd design it with pens and paper and pencils, and then each one of these letters would be carved into a piece of steel to make the punch, and the punch would make the matrix, and then you'd sell the matrix. And this was how we used to distribute fonts. And waiting in the wings is the thing that was going to wipe out linotype machines. Computers. Now, by about end of 1970, that's kind of when the linotype machine stopped being the best way of doing this. It took about another 10 years to die out completely. We had computers. We had computers that could do text, and they did it using teleprinters, heavily modified mechanical typewriters, so they were still using hot metal and ink to put marks on a page. But we fast forward another decade or so, the end of the 1970s, we start seeing home computers, things which are cheap enough you can have one in your house. Now, ASCII exists at this point. That's been around for about 15 years. There is an accepted convention, a capital A, 65, a lowercase a, that's a 97, a backslash is a 92. We have this consensus on which letter is which maps to which number, which numeric code, but ASCII doesn't tell you how to actually draw the letter. So we're going to push a key on our late 1970s home computer. We're going to press A, and when we do that, the keyboard controller spits a 65 into our computer's input buffer. That goes into a character generator chip. Basically a massive lookup table in ROM. We find this value. Now we need that value in binary. Anyone know that value in binary off the top of your head? Anybody? No? All right. It looks like this. But then we're going to take those binary digits and we're going to turn them from a long string into a matrix. Literally a map of bits, a bit map. And we're going to rasterize that. If it's a 1, that's a block. If it's a 0, it's blank. And that's how we get the letter A. This is a bit-mapped font. Now, these things work fantastically. They are fast. They use very little computing power. If you look at the signs on railway stations, bitmap fonts are still used in all kinds of applications. And they were being used to print books. But end of the 1970s, you could use your computer to create a document like this, but you wouldn't see it until it came back from the typesetters. What you could see was this. Because there is this term that floated around when I was first getting into computers, WYSIWYG. What you see is what you get. And at this point, this is what you saw, and that's what you got. And they didn't look the same at all. Now, when you go digging into the history of technology, there are two things that kind of stand out. One is the number of things that, when they were first announced, were just the most amazing, revolutionary thing anyone had ever seen. And now we just take them for granted, and all of us do this stuff all day, every day. And the other thing that stands out is how many of those ideas came from the same company.
Today we celebrate the first glorious anniversary of the Information Purification Directives. We have created, for the first time in all history, a garden of pure ideology. contradictory thoughts. Unification of thoughts is more powerful a weapon than any fleet or army on earth. We are one people, with one will, one resolve, one cause. Our enemies shall talk themselves to death, and we will bury them with their own confusion. We shall prevail.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
Now, there's a bunch of things about that commercial. That ad during the Super Bowl. Why would anyone use the most expensive advertising slot available in television to sell a computer? Nobody had done that before. It was directed by Ridley Scott, who'd already done Alien and, you know, the movies that kind of established him as a major Hollywood director. But Apple were doing revolutionary things. Now, when they created the Macintosh was kind of the first computer where you could get something on your screen that looked like what was going to get printed. And it happened thanks to a couple of different factors. One of them is this person. Apple didn't license fonts from Linotype or Monotype. They created their own. And Susan Kare designed most of them. And some of them were obviously copies. Like they had one called Geneva, which was obviously a Helvetica copy, and one called New York, which was a copy of the Times New Roman. And some of them were classics in their own right, like this one. This is Chicago, which was the system font on the Macintosh, and then 20 years later, when they shipped the iPod, that had the Chicago font in it. There was a piece of software called PageMaker that would let you actually compose documents on your screen, but the most expensive computer that Apple made in 1984, the most powerful computer that Apple made in the 1980s, was not a computer. It was a printer, the Apple LaserWriter. The Mac cost about $2,000. The LaserWriter cost $7,000. The Mac had an 8 megahertz CPU. The LaserWriter had a 12 megahertz CPU. And the reason why they did this is that those fonts, they came as a bitmap version that you used on your screen, on your desk, and they came as a high-quality vector version using this new PostScript language that had been invented by Adobe that would let you print high-quality proofs of what you could see on your screen. Now, the problem with bitmap fonts is they look terrible when you scale them up. So the way printers work, say we want to draw a circle. We're going to draw a circle. Now, I realize that we're in Europe where they use the metric system, but printing works in inches. It just does. We're going to draw a circle here, and we're going to draw a 1-inch circle at these coordinates. So we got this bounding box around the outside. So what we're going to do is we're going to say, all right, there's our center, there's our coordinates, 4 inches by 4 inches into the page, radius 0.5, so it's a 1-inch wide circle. So for every point in that circle, we are going to do a calculation. We're going to say, well, if this point minus 4 squared plus that minus 4 squared is greater than this, that means it's inside the circle, otherwise outside the circle. And so we are going to repeat that calculation for every point. Now, the LaserWriter was 144 dots per inch printer. So to do a 1 by 1 inch circle, we had to do 20,736 sets of square sum calculations, which took a while. It's not remotely fast enough to do on real time in the screen in front of you. Drawing a document took time. If you want to draw actual letters of the alphabet, you want to draw your lowercase o, well, now you've got a circle and an ellipse, and you need to calculate all the points that are inside the big one, but they're not inside the little one. And if you want to draw like a lowercase b, it's like, okay, well, we got the bowl, we've got the upright, we've got the little serifs on it, we've got that in the middle, but we don't want to draw that one or that one or that one. So you've got to perform these calculations, 10, 15, 20 calculations times 144 dots per inch. This is slow. This is why the LaserWriter was the machine with all of the horsepower in it. Now, by the sort of end of the 1980s, it was becoming clear that computers were getting faster, screens were getting better. The next generation of desktops was probably going to use a similar font technology to this. But it wasn't going to use PostScript. There's two reasons. One, PostScript was it cost money. If you wanted to license it, then you had to pay Adobe a bunch of money, which was fine when you were selling a $7,000 printer. But if you were trying to put $1,000 PCs on everybody's desk, that was a significant chunk of your profit share gone. But the other problem, the font system built into PostScript was called Type 1. And Type 1 fonts didn't look good on screens. You got 144 dots per inch on your laser printer, beautiful. brilliant, nice, crisp. We're trying to draw it on screen. We've got maybe 6 by 9 pixels. So first of all, let's say, well, let's color in any pixel which is completely inside the letter. Yeah, that doesn't really, okay. Let's try a different algorithm. Let's color any pixel where the center of the pixel is inside that letter. And yeah, you can see it's a B, but it doesn't really look, like I said, a Times New Roman type B. There's an approach that we've seen used on various devices, which is called anti-aliasing, where if a pixel is entirely inside the letter, it's 100% black. If it's completely outside, it's 0% black. And anything else, we shade it according to how much of it is inside the letter. Now, this kind of looks a little better, but it's still not perfect. It's not sharp. It doesn't have these kind of nice, crisp edges. So Apple and Microsoft kind of got together, and Apple went, hey, do you want to screw Adobe on their licensing? And Microsoft went, oh yeah, we like the sound of that. And they put their heads together, one of the very few collaborations that's ever emerged out of those two companies, and they came up with a system called TrueType. And TrueType used the same vector system as Type 1 fonts, but it also included something called hinting. And hinting was a way of taking the outline and going, look, if you draw this font at this exact number of pixels, actually draw this instead. And so you got these beautiful, crisp edges coming out of these fonts. Now, this shipped in macOS System 7 in 1987-88, and then it shipped in Microsoft Windows, not in Windows 3.0, which is why no one remembers Windows 3.0. It shipped in Windows 3.1. And you could go into your control panel, and you could open up your fonts, and there was this whole thing in there about TrueType. This font looks the same on your printer as it does on your screen, and if you zoom in real close on Windows 3.1, you can see the hinting. You can see those pixel-perfect font outlines. Every one of those was kind of designed one pixel at a time, like carving letters into steel 100 years earlier. The same kind of degree of effort and precision. Now, at this point, typography on screen kind of became a solved problem for about a decade. The most interesting thing, I think, that happened to digital type in the 90s wasn't an innovation or a technology or a protocol or a standard. It was a font. And it's a font that has kind of a funny backstory. This is Microsoft Bob. Microsoft Bob was a replacement for the Windows Program Manager that would make using your computer like being in your house. And if you clicked the writing pad on your desk, it would open a word processor. And if you clicked the clock on the wall, it would open your calendar and your appointments and things. And Microsoft Bob shipped with Rover, your little digital animated assistant. And one of the typographers working at Microsoft, he saw an early preview of this thing. Vincent Conner was his name. And he quite reasonably went, why is the dog talking to me in Times New Roman? Like, that doesn't look like a cartoon dog kind of a typeface. And so he set out to design a font that would go better with this style of interface, influenced by comic books, a sensory font called Comic Sans. Now, Comic Sans did not ship in Microsoft Bob because it didn't fit. The letters were too big. Microsoft Bob shipped. Actually, the weird thing, possibly the most lasting contribution to this is that Microsoft Bob's product manager was Melinda French, who then ended up marrying Bill Gates, and that's the project where they met. So history's greatest contribution is probably the Gates Foundation. Microsoft Bob was cancelled after about a year. Steve Ballmer said, it's a great example of somewhere where we realized we were making a horrible mistake and we should probably stop now. But Comic Sans MS ended up getting shipped with the Plus Pack for Windows 95. And it went everywhere. Now, Comic Sans is a perfectly good typeface. See? It's clear, it's readable, it's friendly. The problem is the people. The reason why Comic Sans is hated so much is that it keeps cropping up in places where they shouldn't have used a playful childhood comic book font. I've seen it on notices in hospitals aimed at people who have serious illnesses. I've seen it used on all kinds of official things. Danger of death, do not interfere with this equipment, set in Comic Sans. I found an example on Reddit of somebody who, after they buried their dead father, they got the invoice from the funeral home in Comic Sans. And I once, many years ago, I applied for a bank loan to buy a house, and the chief accountant in my company wrote the letter to the bank in Comic Sans, because nothing says childish and playful like borrowing enough money to buy a house, right? It's a fine typeface. It's just used in all kinds of bad places. But the next kind of chapter in our story of typography happened thanks to these things. Flat screen monitors. Now, if you take a screenshot and you zoom way in, you might notice at a certain level that it's not crisp black and white text anymore. You get these kind of blue and orange colored fringes on it. Now, this is a digital zoom. We've taken the pixel, we've taken the information in the pixel buffer and said, make that bigger. This is not the same as what you get if you put your camera in front of your screen with a macro lens on it and zoom that right in and enlarge the same thing. Because if you do that, what you see is that the white on your screen is little red, green, blue, red, green, blue, red, green, blue pixels. And when they're all lit up, your eye can't see the pixels. We just see white. But if you zoom in far enough, you can see the individual details. So the reason why you get these colored fringes, we're going to take our letter B, we're going to draw it on a pixel grid, but we're going to exploit the fact that that pixel grid is actually red, green, blue, side by side. And we are just going to switch on the ones which are outside our character outline. Now, when we do that and zoom in, that combination of pixel, sub-pixel elements gives us these colors, but the way our eye perceives it is we actually see this. And so we get triple the horizontal resolution by exploiting the hardware that our flat screen display is actually made from. Now, Microsoft patented this in 1998. They announced it at Comtex. It's called ClearType. It's built into every version of Windows ever since. But there is some dispute as to whether Microsoft actually invented this, because the Microsoft Basic Reference Manual from 1980 explicitly talks about the fact that on the Apple II, there was a green and a purple pixel side by side, and you could switch them on and off independently to get high-definition displays. And Steve Wozniak, who built that hardware, went on the record as saying, well, yeah, of course we knew how to do that. How else do you think we got high-resolution graphics out of the Apple II in 1978? Now, while we're talking about the Apple II, I want to mention a guy called Michael Koss, because Michael Koss built what I think is the tiniest font that has ever actually been used for anything. He built like a telnet program for the Apple II in 1982, and he built a font that was 3 pixels by 5. Probably the tiniest usable typeface that has ever been shipped, which is amazing. One, because it meant he could get 72 columns on an Apple II plugged into a television set, but also because each one of these fonts is less than 16 bits. The pixel map for each one of these fits inside 2 bytes, which makes it the tiniest font I think anyone has ever actually used for anything. Now, by the 90s, mid-90s, we didn't care about your font being 16 bytes because we had loads of room. You went out, you bought CorelDRAW, it came on CD-ROM, 650 megabytes, and hey, let's throw in another one, which is full of fonts, like Comic Sans, in case anyone didn't have it by that point. But then something happened that meant we suddenly started caring about file sizes again, which was the web. Now, the web used to look like this. The dot-com boom. The early days of the web were fantastic. It was a complete free-for-all. None of us had any idea what we were doing. Everyone put up a website with a little animated under-construction GIF to prove that they were working on it. They just hadn't figured out yet what this web thing was actually for. And most of us got onto the web using dial-up modems, which were slow. Nobody was going to wait for your website to load. If it wasn't there within about 10 seconds, they'd get bored and they'd go and find another one. So you were not going to include fonts, heavyweight graphics. You had to draw your website using the fonts that your user already had on their computer, which is why they looked like this. Now, this is the Space Jam website, which is a beautiful relic. This was Warner Brothers' big-budget movie promotional marketing campaign in 1996, but it's still up. They never took this site down. This is still there. You can still go and see it today exactly as it looked in the late 90s. So how hard can it be? We're going to use a font. Well, we don't know what fonts you've got. Maybe you're running Windows, Mac OS. Maybe you're running Solaris. Maybe one of you is using a web TV set-top box so you can get on the internet without having to buy a computer. We had no idea what fonts you were using, so we had to kind of make it up. We used a thing called fallback font rendering. This kind of rule, which is still used on websites all around the world, says, hey, please draw my website in Futura semi-bold. And if you can't find that, use Helvetica. And if you can't find Helvetica, use Arial. And if you can't find that, anything sans serif will do. We're not too fussy. Now, there's not a whole lot of takeaways in this talk, but I am going to give you one thing you can take away and use on your own time. And we're going to need 3 things. First, we need somebody you don't like. Who runs Microsoft Windows? If you're a Linux user, this is all Windows users, so work on any of them. Second, we need this. FontForge, it's a piece of brilliant open source software for creating and managing fonts. And what we are going to do, we are going to go onto defont.com, and we're going to find something really cool, like abstract groovy. We're going to download that font, and we're going to open that TTF file in FontForge. And then what we're going to do is go onto the font information element, font info, and we're going to change the name to Helvetica Neu. Now, Helvetica Neu was designed in Switzerland in the 1960s. But when Apple launched their high-resolution iPad and iPhone displays, Retina displays, about 10 years ago, they used Helvetica Neu as the kind of flagship typeface for their new displays. And so lots of people went, ooh, I'm going to use that font on my website because I want to be as cool as Apple. And a lot of them didn't do it very well. So we're going to take our abstract groovy font we've renamed to Helvetica Neu. We're going to export it as a TTF. We're going to send it to our friend on Windows and go, hey, check this out. And they are probably not going to notice that buried up in the top there it says Helvetica Neu. They're just going to go, oh yeah, I'll install that. That's fine. And they're not going to notice anything. Not immediately, not for a while, because there's a lot of websites out there that just say, hey, if you can find Helvetica Neu, use it. They haven't packaged it or included it. They just said, if you find it, use it. So our friend is going to happily browse around, and then they're going to go to download WhatsApp, and they're going to be like, that doesn't look quite right. Or they're going to get an invoice from the iTunes store and be like, wow, Apple have gone kind of groovy. Or they're going to log into the software they use to do their business accounts and be like, oh, yeah, 1970s disco business, all right. Or maybe you're just going to do this to yourself because the web is a much more fun place when it looks like a 1970s disco. Do you want to join the digital interbank network? Like, doesn't that look much happier in this than it would in Helvetica Neu, the real font? This was just one of the challenges we had figuring out web typography. And part of the reason for this is when the web went mainstream, companies were like, we want our website to be an extension of our brand. We want going to our site to feel like going into our showroom or looking at our printed catalog. And the design, typesetting, visual graphics industry, they had literally centuries of experience. They've written book after book after book. There's an entire book about how to teach design history. That's kind of how embedded this stuff was. Centuries of experience designing books, record covers, posters, airport signage, and all of it's fixed. You go to them and you say, yeah, we don't know what size it's going to be. Like, can you design it now and then the user might resize the window? And they lost it. They're like, no, you can't let the client choose the size. And lots of them are like, we're not doing it. We'll give you a PDF that you can download from your website, which is still how restaurant menus get published online today. Meanwhile, the programmers, the developers, we don't care about design. We build apps that look like this. It's perfectly usable. And suddenly someone's saying to us, you need to learn about line spacing. You need to learn about font width and kerning and type. And we're like, no, we don't want to learn. Just, no, fix it. So there was this very, very kind of uneasy tension. We eventually, mostly, resolved it. And one of the big milestones in the history of digital typography was 2009, a thing called the Web Open Font Format, WOF. And this meant that you could actually say, hey, I want you to draw this website using this font, and by the way, here's the font. Now, one, this wouldn't install the font on your system. It would just use it in your browser's rendering engine. So a lot of the security considerations, you wouldn't get websites interfering with one another. But it also meant that you could supply fonts that weren't just about drawing letters. Now, has any of you ever got an email from somebody at your job that ends with like a, this candidate CV looks great. I know they said in the interview their favorite font is Papyrus, but I'm sure we can make an exception just this once, J. And you've got this weird little capital letter J hanging on the end of it. Now, Microsoft created a font in the early 90s called Wingdings. And Wingdings was based on a concept called dingbats. And in dingbats, in printing, a dingbat is a thing that isn't a letter. It's like a bullet point or a playing card. It's a printer's decoration, printer's ornament. Now, in the early 90s, we didn't have Unicode yet. Not really. So the only way Wingdings could work is that they had to pick letters that were being used for something else and say, well, if you change it to this font, that letter is going to look like something else. In the early 90s, there was a computer consultant in New York who had a font set to Wingdings. And, the way that this worked, like A would be this. Number 2 would be a little document. A W would be this diamond here. And our chap in New York is typing away one day in Wingdings, and he types NYC for New York City, and he notices that N is a skull and crossbones, Y is a Star of David, and C is a thumbs up. So he gets on the phone to the New York Post and says he has proof of an anti-Semitic conspiracy within Microsoft. The New York Post, being responsible journalists, does exactly what we'd expect them to do and tells him to shut up and go home and put his... No, they run it on the front page of the paper. Secret Microsoft anti-Jewish conspiracy. Now, of course, there is no such thing. It's a complete coincidence. But this kind of does the rounds every couple of years. Someone finds an old news story. And when Microsoft created Webdings in 1998, which shipped with Windows 98, they had kind of noticed this was doing the rounds, and so in Webdings, if you type NYC, it says, I love New York. And that capital J, Microsoft Outlook 2010, if you typed a smiley face in your email, it would autocorrect it. But because we didn't have emoji, it autocorrected it by changing the font. And the smiley face is a letter J in Wingdings. So if you were using Outlook 2010, you'd get a smiley face. If you were one of the billion or so human beings on this planet who was not using Outlook 2010, you'd get a J. Now the reason why I remember this is that in the 2000s, early 2000s, I was working at a company that used Microsoft Outlook, and my boss's name was J. Now I want you to just look at these two emails and see, you know, did these send a different message? Maybe? Now this idea, being able to include a font that does not do characters, this is fantastic. My favorite example of this is Font Awesome, which gives you this amazing library of icons and, you know, visual elements, pictograms, ideograms, all the kind of things we've talked about. And it does it all as a font that you can just bundle and include with your website. They even have R2-D2 in there. Although he's not actually R2-D2, he is generic astromech droid, because somebody doesn't want to get sued. But the wonderful thing about this is because it's a font, it's a vector, it has infinite resolution. This isn't just a picture of R2-D2, sorry, astromech droid. This is a set of mathematical instructions that says we don't care what hardware you're running. You know, iPhone, Samsung phone, laser printer, maybe you've got one of those neural jack optical nerve implants with the infinite resolution. Draw the best R2-D2 that you possibly can. And this is fantastic because it decouples typesetting from the restrictions of the hardware. 2007, Amazon launched Kindle. It's the first mainstream consumer device with an e-ink display. Now, I read voraciously. I read a couple of books a week. I have done my entire life. If you'd said to me, you're going to read books on a screen, I'd be like, no, I'm not. I'll read email on a screen. I'll read documentation on a screen and websites. I'm not going to read an entire book on a screen. But then Amazon came out with e-ink. The first time I saw a Kindle, I thought it was fake. I picked one up in a store. I was like, there's no way this thing is real. Like, they've printed out like a plastic screen and glued it on. And then I pushed a button and the screen changed and it was like, wow. Like, you know, and now we take it for granted. You know, e-ink is ubiquitous. And the brilliant thing about it, the way e-ink works, we've got all these tiny little capsules inside with black and white charged particles. And e-ink only uses power when it's changing. So you flip the page, and each one of these tiny capsules gets zapped by a thing that says, hey, negative charge, repel all the black particles to the top. There, you're black now. And it'll just stay black for weeks, months. This is why Kindles will run for a month on a single battery charge. A few years ago, I swapped my Kindle for one of these. This is an Onyx Books tablet. It's an e-ink tablet that runs Android, and you can hook up an external keyboard to it and stuff. And it's fantastic. It's the only device I've ever had that is actually nice to do crossword puzzles on. And they just brought out a color e-ink display. And I'm looking at this, I'm like, ah. I should get one of those. That just looks cool. I don't know what I'd need it for, but it just looks like a nice thing. And, you know, the state of the art with display technology. Meanwhile, across the way, mobile phone screens are just getting better and better to the point where you can't even see the pixels anymore. And so much of this technology, you know, this ingenuity, linotype machines and bitmap fonts and subpixel font rendering, it almost doesn't matter anymore. Because we have devices that are so fast, with displays so good, that we can just say, yeah, draw this font there, make it look amazing, and it just does it. It works, and it happens. And we are at this convergence now of these stories. We've got 5,000 years of typography and ideograms and pictograms, and you might think that's history, but every year when Unicode bring out a new batch of emoji, and people start WhatsApping their friends, and those emoji take on these in-jokes and hidden meanings. We're still part of that story. It's still going on. And we've got 500 years of hot metal print and typography and type design, and we've got 50 years of digital devices and bitmap fonts and optimization and PostScript and TrueType, and we've got whatever starts here and where that's going to go. And I want to leave you with one of the absolute, like, holy shit, we are living in the future moments. Anyone read this book? Neil Stephenson, Diamond Age. I read this in paperback in the late 90s. It's a science fiction story about nanotechnology and steampunks and, you know, kind of landscape scale engineering, all these astonishing ideas. And one of the things in it, one of the fictional futuristic devices, is an electronic book. And I was reading this book, rereading it on my Kindle a little while ago, and I was sat outside on a railway station platform at night, and I'm reading it, and this comes up. And I just had this, holy shit. Like, this is the thing that was science fiction in the 1990s. You know, the paper glowed softly, the letters stood out, crisp and black. It was literally a wow moment. Now, we are living in the future. Somebody sent me this yesterday. Television newspapers, you know. Will we ever have a day when we can read the news on a television screen? Well, it's not a television screen, but it's come true, you know. Is it even possible? Well, yeah, can it be done? We've done it. We do this every day. You get any book from the 1970s, 1980s that's talking about the future of society, and it's full of stuff that we do already. We've got solar. Okay, we don't have flying cars. They got really fixated on flying cars. We have solar-powered houses, you know. We have all of this smart computers. We have all this kind of technology. We are living in the future. Things that were science fiction 10, 20 years ago are happening every single day all around us. It's great fun being part of that story. So take it away, go out there, build awesome stuff, and if you do ever get the chance to see a linotype machine, go and check it out, because they are fantastic. Thank you. Actually, thank you.
Thank you.
Oh, thank you.